Welcome to our video on Azure Virtual Networks. Azure Virtual Networks, or VNets, are the fundamental building blocks for your private network in Microsoft Azure. Think of a VNet as your own data center network, but with the benefits of the cloud. Azure VNets offer three key benefits: scale, allowing you to easily expand or shrink your network; availability with built-in redundancy; and isolation, providing a secure and private environment. In this video series, we'll cover what Azure VNets are and why you need them, key components of virtual networks, how Azure networking works, and how to create a virtual machine connected to a VNet. Let's explore Azure Virtual Networks together. An Azure Virtual Network, or VNet, serves as a logical representation of your network infrastructure within the Microsoft Azure Cloud Platform. With a VNet, you have the flexibility to define your own private IP address space, typically using addresses from RFC 1918, ranges such as 10.0 to 0.0/16. One of the key capabilities of Azure VNets is the ability to segment your network into multiple subnets, each with its own address range. A VNet essentially provides you with an isolated portion of the Azure cloud, giving you control over your network environment while maintaining security and privacy. You can think of an Azure Virtual Network as having your own private data center network within the Azure cloud infrastructure. Azure Virtual Networks enable secure communication for your cloud resources. VNets facilitate three essential communication patterns crucial for modern cloud applications. This communication capability forms the foundation for distributed applications and hybrid cloud solutions. First, resources within the same VNet can communicate securely with each other, like a web server interacting with a database. Second, resources can communicate with the internet, allowing users to access your applications from anywhere in the world. Third, resources can communicate with your on-premises networks through secure connections, enabling hybrid cloud scenarios. These communication capabilities make VNets essential for building robust cloud solutions that integrate with existing infrastructure. Azure Virtual Networks provide two critical functions: isolation and filtering. Virtual networks provide a secure and isolated environment for your applications. Isolation means your workloads are logically separated from other Azure customers, providing a secure environment for your applications. You can also create multiple subnets to separate different environments and establish secure boundaries for your workloads. You can filter network traffic using network security groups, or NSGs, which act as firewalls around your subnets. Azure Firewall provides advanced protection for your virtual networks, giving you even more security capabilities. NSGs in Azure Firewall allow you to control both inbound and outbound traffic, creating rules that specify which traffic is allowed or denied. When traffic reaches an NSG, the rules are evaluated to determine if the traffic should be allowed or blocked. NSG rules are evaluated by priority, from lowest to highest number. Each rule specifies ports, protocols, and whether to allow or deny the traffic. Through isolation and filtering, Azure Virtual Networks provide a secure environment with granular control over network traffic, effectively defending against unauthorized access. VNets provide powerful routing capabilities and seamless integration with other Azure services. Let's first explore how VNets enable custom routing with route tables and user-defined routes. By default, Azure creates system routes that automatically direct traffic between subnets. However, with user-defined routes, you can customize how traffic flows through your network. Route tables allow you to override Azure's default routing behavior. This enables scenarios like forced tunneling through a network virtual appliance or directing traffic through security appliances. Another key benefit of VNets is their integration with other Azure services, particularly through Azure Private Link. Azure Private Link provides private connectivity to Azure Platform as a Service offerings from your virtual network. With Private Link, traffic between your VNet and the service traverses the Microsoft Backbone network, eliminating exposure to the public internet. This integration enhances security by keeping your data off the public internet while still providing full access to Azure services. When creating an Azure Virtual Network, you must specify an address space. An address space defines the range of IP addresses that will be available within your virtual network. Azure Virtual Networks should use private IP address ranges as defined in RFC 1918. These private address ranges are not routable on the Internet, which makes them ideal for internal networks. Address spaces are specified using CIDR notation. For example, 10.0.0/16 represents over 65,000 available IP addresses. It's crucial to choose an address space that doesn't overlap with any other networks in your organization. Overlapping address spaces can cause routing conflicts and connectivity issues. When planning address spaces for Azure Virtual Networks, follow these best practices. Plan for future growth by using larger address spaces. Document all address spaces used in your organization. Consider your VNet peering and hybrid connectivity requirements, and use different address ranges for different regions or environments. Remember, properly planned address spaces are essential for successful Azure networking and avoiding future complications. Subnets are a fundamental component of Azure Virtual Networks, allowing you to segment your network into smaller, manageable sections. When you create subnets, you allocate portions of your VNet's address space to each subnet. Think of it as dividing a large office building into separate departments. Subnets provide several important benefits for your cloud architecture. They enable network isolation between different workloads and allow for granular security control using network security groups. When deploying Azure resources, each resource must be placed in a specific subnet. Resources inherit the network properties and security rules of their subnet. A common implementation is the three-tier architecture, where you create separate subnets for web, application, and data tiers, each with appropriate security and access controls. Resources in different subnets can communicate with each other by default, but this can be controlled using network security groups or Azure Firewall. In summary, subnets allow you to create logical network segments within your virtual network, helping you organize resources and apply differentiated security policies based on your application's needs. Network security groups, or NSGs, are a fundamental security component for Azure Virtual Networks. They control both inbound and outbound traffic to your Azure resources, functioning as a distributed firewall. NSGs can be associated with subnets or individual network interfaces to control traffic flow. When traffic attempts to enter your network from external sources like the Internet, it first encounters the NSG. NSG rules are processed in order of priority, from the lowest number to the highest. Each rule has a priority number between 100 and 4096, with actions to allow or deny traffic based on specific criteria. When traffic arrives, Azure evaluates each rule in ascending order of priority. Here, Rule 100 is evaluated first. If the first rule doesn't match, evaluation continues to the next rule. If traffic matches a deny rule or reaches the default deny rule at the end, it will be blocked. NSGs can be used to define security rules for each subnet, providing a layered security approach. Here are some best practices when implementing network security groups in Azure. Create subnet-level NSGs for group security and use NIC-level NSGs for specific virtual machine requirements. Always follow the principle of least privilege and create specific rules rather than overly permissive ones. To summarize, network security groups are a critical component for securing your Azure Virtual Networks. Azure Firewall is a key component in your virtual network security architecture. It's a managed, cloud-based network security service that protects your Azure resources by filtering traffic entering and leaving your virtual network. Azure Firewall inspects all traffic between the Internet and your virtual network, providing a secure boundary. It acts as a barrier that inspects all incoming and outgoing traffic based on predefined security rules. Azure Firewall offers advanced threat protection and centralized network security policy management. Common use cases include restricting outbound traffic, implementing network segmentation rules, and filtering traffic between subnets within your virtual network. Azure Firewall integrates with Azure Monitor for comprehensive logging and analytics of all traffic. Route tables are a critical component of Azure Virtual Networks, controlling how network traffic is directed. By default, Azure creates system routes that enable traffic between subnets, to the internet, and to Azure services. User-defined routes, or UDRs, let you customize traffic flow by overriding system routes, enabling inter-VNet connectivity and routing through network virtual appliances. A route table contains entries that define where traffic should be directed based on destination IP addresses. System routes, like the default internet route, are created automatically. User-defined routes can direct traffic to specific destinations. For example, this route sends traffic to VNet 2 through a network virtual appliance. Another example is routing traffic destined for on-premises networks through a VPN gateway. Let's see how route tables work in a practical scenario. Here we have two virtual networks and an on-premises network. A network virtual appliance can be placed between VNets to provide advanced security or networking features, and a VPN gateway connects the Azure environment to on-premises networks. Now let's connect these components. With user-defined routes, traffic from VNet 1 to VNet 2 is directed through the network virtual appliance. Similarly, traffic to on-premises networks is routed through the VPN gateway. User-defined routes provide several important benefits. They enhance security by forcing traffic through inspection points like firewalls. They give you precise control over network paths, allowing you to define exactly how traffic flows between resources. They enable network optimization by directing traffic based on specific requirements like latency or bandwidth. And they facilitate hybrid connectivity by seamlessly integrating Azure with on-premises networks. IP addresses allow Azure resources to communicate with other resources, virtual networks, on-premises networks, and the internet. Azure supports two types of IP addresses, private and public. Private IP addresses are used for communication within a virtual network and aren't directly accessible from the internet. Public IP addresses allow Azure resources to communicate with the internet and other Azure services. They are globally unique addresses. Azure offers two allocation methods for IP addresses, dynamic and static. Dynamic allocation means the IP address is assigned automatically and may change when a resource is stopped and started. Static allocation means the IP address is assigned manually and remains the same until it's deleted or modified. Let's see how virtual machines use IP addresses in Azure. Here's a virtual network with a subnet containing 3 virtual machines. Each VM has a private IP address allocated from the subnet range, which is used for communication within the virtual network. Private IP addresses enable VMs to communicate with each other within the VNet. VMs with public IP addresses can also communicate with the internet, while VMs with only private IPs cannot directly access or be accessed from the internet. Note that public IP addresses are available in basic or standards KUs, with standard providing more features like zone redundancy and improved security. Understanding IP addressing in Azure is crucial for proper network design and connectivity. In Azure, virtual network creation is the first step in building your cloud network infrastructure. When creating a VNet, you'll define it with a specific IP address range using CIDR notation. For example, 10.0.0/16 provides 65,536 IP addresses for your virtual machines and services. It's crucial that this address range does not overlap with any other networks in your organization. Otherwise, routing conflicts will occur. Azure offers multiple ways to create a virtual network. You can use the Azure portal for a visual interface, PowerShell for scripting, or the Azure CLI for command line automation. Let's walk through the VNet creation process in the Azure portal. First, search for virtual networks in the Azure portal search bar. Next, click the Create button to start the VNet creation wizard. On the Basics tab, configure essential settings like subscription, resource group, name, and region. Define your IP address space on the IP addresses tab. This is where you'll enter your CIDR block. Finally, review your settings and click Create to deploy your virtual network. Once created, your virtual network becomes the foundation for deploying resources in Azure. After creating a virtual network with its address space, the next step is to divide it into subnets. Subnets are logical divisions of your virtual network. Each subnet contains a portion of the virtual network's IP address space. Let's divide our virtual network into three subnets for different purposes: web servers, application servers, and databases. Each subnet has its own IP address range, or CIDR block, which is a portion of the VNet's address space. Subnets help you organize resources by grouping related services together. For example, all web servers can be placed in the web tier subnet. Subnets also help you apply specific security rules. You can associate network security groups with each subnet to control traffic flow. Dividing your VNet into subnets provides several benefits: logical organization of resources, targeted security policies, controlled routing between tiers, and isolation of sensitive workloads. Once you've created your subnets, you're ready to deploy Azure resources into them and configure specific security rules for each tier. After creating a virtual network and dividing it into subnets, the next step is deploying resources. Azure Virtual Networks are organized into multiple subnets, each with a specific purpose and IP address range. You deploy Azure resources, such as virtual machines, into specific subnets within the VNet. Let's start with web servers in the front-end subnet. Next, application servers are deployed into the application subnet. Finally, database servers go into the database subnet, completing our three-tier architecture. Organizing resources into different subnets allows you to control communication between them. Here, web servers can communicate with application servers, and application servers can communicate with the database server, but there's no direct connection between web and database layers. Deploying resources to specific subnets creates security boundaries, enforces network segmentation, and allows you to apply different security rules to each subnet. This network architecture is common in production environments, where separation of tiers improves security and manageability. Network security groups, or NSGs, are a fundamental component of Azure Virtual Network security. NSGs act as virtual firewalls, controlling the flow of traffic to and from resources within your subnets. Without NSGs, all traffic could potentially flow in and out of your subnet resources, creating security vulnerabilities. NSGs are placed at the subnet level or network interface level, filtering traffic based on rules you define. Each NSG rule consists of several key components that determine how traffic is filtered. These include a unique name, priority number that determines processing order, source and destination addresses, port, protocol, and the action to take, either allow or deny. Let's see NSG rules in action with a practical example. Here, we have a web server in a subnet protected by an NSG. The NSG allows HTTP and HTTPS traffic from the internet to reach the web server, while blocking other potentially harmful traffic like FTP or Telnet. This selective filtering is the essence of network security configuration in Azure Virtual Networks, allowing legitimate traffic while stopping potential threats. Azure automatically routes traffic between subnets within the same virtual network. When you deploy resources like virtual machines in different subnets, they can communicate with each other by default without any additional configuration. This built-in routing means VM1 in subnet 1 can automatically communicate with VM2 in subnet 2. Traffic flows directly between the subnets. However, you may want to customize how traffic flows for security or compliance reasons. This is where user-defined routes come in. User-defined routes, or UDRs, allow you to override Azure's default routing behavior. A common scenario is routing traffic through a firewall for inspection. With custom routing, traffic from VM1 is now directed through the firewall before reaching VM2. This allows for packet inspection and applying security policies. There are several scenarios where you might implement custom routes in Azure. Custom routes are implemented using route tables in Azure. These are resources that contain a set of rules or routes to direct network traffic. By combining automatic routing and user-defined routes, you can create sophisticated network topologies that meet your security and connectivity requirements. Azure Virtual Networks can connect to on-premises environments, enabling hybrid cloud solutions. One method to connect your Azure Virtual Network to on-premises is using a VPN gateway. This establishes an encrypted tunnel over the internet. Alternatively, ExpressRoute provides a private, dedicated connection to Azure that doesn't travel over the public internet, offering higher reliability and lower latency. VPN Gateway creates an encrypted tunnel that securely transmits data between Azure and your on-premises network over the internet. ExpressRoute provides a private connection with consistent, high-throughput performance that bypasses the public internet entirely. Connecting your on-premises network to Azure creates a hybrid cloud environment with several key benefits. These hybrid connections allow your Azure resources and on-premises systems to communicate seamlessly, providing flexibility for your IT infrastructure. When creating an Azure virtual machine connected to a virtual network, the first step is to create a resource group. A resource group serves as a logical container for your Azure resources, organizing related components of your solution. Let's see how to create a resource group in the Azure portal. First, select your Azure subscription from the drop-down menu. Next, enter a unique name for your resource group. This name must be unique within your subscription. Then, select a region where your resource group will be stored. It's best to choose the same region where your VM and VNet will be deployed. Finally, click the Create button to create your resource group. Once created, your resource group is ready to host the virtual network and virtual machine we'll create in the next steps. Remember, a well-organized resource group helps with management, access control, and cost tracking throughout your Azure deployment. To create a virtual network in Azure, first navigate to the Azure portal and search for virtual networks in the search bar. Select Virtual Networks from the search results. Once on the Virtual Networks page, click on the plus Create button to begin creating a new virtual network. This will open the Create Virtual Network form. The form is organized into multiple tabs, starting with the Basics tab. In the Basics tab, you'll need to provide essential information about your virtual network. First, select your Azure subscription from the drop-down menu. Next, select an existing resource group or the one you just created. Then give your virtual network a descriptive name that identifies its purpose, for example, My VNet. Finally, select the Azure region where you want to deploy the virtual network. Choose a region close to your users or other Azure resources to minimize latency. Make sure all required fields marked with an asterisk are filled in correctly. After completing the Basics tab, click the Next button to continue to the IP Addresses tab, where you'll configure the address space and subnets. This completes the initial setup of your virtual network. In the next steps, you'll configure IP address spaces and create subnets within your VNet. In this step of creating a VM with a virtual network, we'll configure the IP addresses for our VNet. After completing the Basics tab, navigate to the IP Addresses tab, where we'll define our network's address space and subnets. First, configure the address space using CIDR notation. The default is typically 10.0.0/16, which provides over 65,000 IP addresses. Next, define at least one subnet within this address space. A subnet allows you to segment your network logically. When you create a subnet, you're allocating a portion of your virtual network's address space. The default subnet uses a /24 prefix, providing 256 IP addresses. You can add multiple subnets to organize your resources. Each subnet can have its own network security group and route table. Ensure your subnet ranges don't overlap and provide enough IP addresses for your current and future needs. Network security groups, or NSGs, act as a virtual firewall to filter traffic to and from Azure resources. To create an NSG, first navigate to the Azure portal and search for Network Security Groups. Select Network Security Groups from the search results. Click the plus Create button to start creating a new network security group. In the NSG creation form, enter the required information. First, select your subscription. Next, select an existing resource group or create a new one for your NSG. Give your NSG a descriptive name that identifies its purpose, such as My NSG. Finally, select the region where your NSG will be deployed. This should match the region of the resources it will protect. Click Create NSG to proceed to the Security Rules configuration. Now it's time to configure security rules for your NSG. These rules determine what traffic is allowed or denied. For inbound rules, you might want to allow RDP or SSH access from specific IP addresses for secure VM administration. For outbound rules, the default is to allow all traffic, but you can restrict this to only allow traffic to specific services or destinations. After configuring your security rules, Review your NSG configuration and then click Create to finalize. Once created, your NSG can be associated with subnets or network interfaces to protect your virtual machines and other resources. In the next step, we'll create a virtual machine and associate it with this network security group. To create a virtual machine in Azure that will connect to our virtual network, we start by navigating to the Virtual Machines service. In the Azure portal, search for and select Virtual Machines using the search bar at the top. After accessing the Virtual Machines page, click on the plus Create button to start the creation process. This opens the Create a Virtual Machine wizard. On the Basics tab, you'll need to enter the required information. First, select your subscription from the dropdown. This determines the billing account for your Azure resources. Next, select the resource group you created earlier. This group's related resources for easier management. Give your virtual machine a unique name. This will be used to identify your VM in the Azure portal. Select the region where you want to deploy your VM. This should match the region of your virtual network. Choose an image for your VM. This determines the operating system. You can select from Windows, Linux, or other specialized images. Select the size of your VM based on your performance and budget requirements. This determines the CPU, memory, and storage capabilities. It's critical to ensure that your VM is deployed in the same region as your virtual network. Otherwise, they won't be able to connect. After completing the Basics tab, you'll proceed to configure disks, networking, and other settings in the subsequent steps. In the Azure Portal VM creation process, we now need to configure the networking settings for our virtual machine. First, select the virtual network you previously created. This is where your VM will be deployed. Next, select the subnet where your VM will be placed. This determines the IP address range available to your VM. Now, associate the network security group you previously created. The NSG will control inbound and outbound traffic to your VM. For external access, you'll need to configure a public IP address. You can create a new one or select an existing one. Let's see how these components connect in your Azure Virtual Network environment. Your VM will be deployed within the subnet you selected, which is part of your virtual network. The VM connects to the network through a Network Interface Card, or NITC, which is protected by the Network Security Group you selected. The Network Security Group acts as a firewall, controlling which traffic is allowed to and from your VM based on the rules you configured. There are additional networking options you can configure based on your requirements, such as accelerated networking for higher performance, load balancing, or application security groups for finer access control. With these networking configurations in place, your VM will be properly connected to your virtual network with the appropriate security controls. Azure Virtual Networks have significant practical implications for both network administrators and end users. For network administrators, proper VNet configuration is crucial for maintaining security, performance, scalability, and cost efficiency. End users benefit from properly configured VNets through secure access, consistent performance, reliable connectivity, and a seamless experience between on-premises and cloud resources. To ensure your Azure Virtual Networks deliver these benefits, follow these best practices for VNet configuration. Failing to properly configure your virtual networks can lead to serious consequences. In summary, Azure Virtual Networks provide a solid foundation for your cloud infrastructure when properly configured, ensuring security, performance, and reliability for your organization and its users. Thank you for watching our Azure Virtual Networks tutorial. In this video, we've covered Azure Virtual Networks fundamentals, their key components, and the process of creating a virtual machine connected to a VNet. Azure Virtual Networks provides secure communication between resources, isolation with network traffic filtering, and seamless integration with other Azure services. For more simplified Azure explanations, don't forget to like, share, and subscribe to our channel.